For exercise, an athlete who weighs 500 newtons climbs stairs for 10 seconds. The athlete's metabolic power is 600 watts, assuming the efficiency of the human body is 25%. So first, we want to determine the metabolic energy expended by the athlete. Alright, so we can figure this out from looking at her power and the amount of time she's climbing for. So we know her power is 600 watts, and let's rewrite that as 600 joules per second. And she does that for 10 seconds, and we can see our dimensional analysis, seconds cancel to give us 6,000 joules as the metabolic energy expended by the athlete. Alright, so we want to find out how much thermal energy is created. So now we need to keep in mind a couple things. So we want to look at this, and we want to look at this efficiency. So we know that she's climbing at a constant speed. She is going up, so that should be positive. There's no spring involved. She's burning chemical energy, and she's creating thermal energy. Now, we want to think about our system as always, and the athlete's included in it, so work's going to be 0. Alright, so we can write out this expression. Delta UG plus delta ETH equals delta ECH. So to figure out how much of this 6,000 joules is going to become thermal energy, we can look at our efficiency. So we know efficiency equals 25%, so 0.25, and it equals what you get over what you had to pay. So what we're getting is delta UG, and what we're paying is delta E chem. So we can see that delta UG is going to equal 0.25 delta ECH. So we can plug that, we can just take this and plug it in for delta UG over here. So 0.25 delta ECH plus delta ETH equals delta ECH. And we can just subtract 0.25 delta ECH from both sides and get ETH, delta ETH equals 0.75 delta ECH. Alright, so the change in chemical energy is going to be her metabolic energy. So we can just plug in that for delta ECH. And I think we're going to get 4,500 joules for the amount of thermal energy created. Alright, so now we can figure out how high she climbed. So we know that she expended 6,000 joules of energy, and 4,500 of it became heat, or thermal energy. So how much of it became gravitational potential? So 6,000 expended minus 4,500 is going to equal 1,500 joules, will be our delta UG. So 1,500 joules, and we can pull out delta UG equals mgy. So she weighs, we have mg as 500 newtons times y. So it looks like that's going to be 3